Imagine a massive asteroid hurtling through space, its path set on a collision course with Earth. This is the scenario scientists once feared with the asteroid Apophis, a giant space rock that could have brought unimaginable devastation to our planet. If Apophis were to strike Earth, the impact would be catastrophic, capable of releasing energy comparable to thousands of nuclear bombs, leveling cities, and triggering tsunamis that could wipe out entire coastlines. But how real is this threat? In this video, we'll delve into the science behind asteroids and other space rocks, explore the true danger posed by Apophis, and examine the incredible work NASA is doing to keep our planet safe from these celestial threats. Asteroid Apophis is no ordinary space rock. Measuring over 1,100 feet in diameter, it's a colossal body that, if it were to collide with Earth, would release energy equivalent to over 1,000 Hiroshima bombs. The resulting explosion would create a blast radius capable of leveling an entire city, and the shockwaves could generate tsunamis with the power to devastate coastlines across the globe. The impact would be nothing short of apocalyptic, with the potential to cause widespread destruction and loss of life on an unimaginable scale. When Apophis was first discovered in 2004, scientists feared the worst. Initial calculations suggested a small but significant chance that the asteroid could collide with Earth in 2029 or 2036. The news sent shockwaves through the scientific community and beyond, sparking widespread concern about the future of our planet. However, thanks to years of careful observation and refined calculations, NASA has since ruled out the possibility of a collision. The asteroid will pass safely by Earth, though its close approach will still serve as a powerful reminder of the potential dangers lurking in our solar system. When it comes to the dangers from space, it's essential to understand the different types of space rocks that could threaten Earth. Asteroids are rocky bodies that orbit the Sun, mostly found in the asteroid belt between Mars and Jupiter. Comets, on the other hand, are composed of ice, dust, and rock, often originating from the distant outer reaches of the solar system. As comets approach the Sun, they develop spectacular tails of gas and dust. Meteoroids are small fragments of asteroids or comets, which, when they enter Earth's atmosphere, become meteors, producing bright streaks of light. If they survive the journey through the atmosphere and reach the ground, they are known as meteorites. Each of these objects poses a different level of threat depending on its size, composition, and trajectory. While asteroids like Apophis are certainly a cause for concern, comets pose an even greater danger. Due to their immense speed and the unpredictability of their orbits, comets can appear with little warning, giving scientists much less time to prepare for a potential impact. In fact, their velocity means that a comet impact could release far more energy than an asteroid of similar size. This was illustrated in the fictional film Don't Look Up, where a comet on a collision course with Earth becomes a race against time for humanity. While the film is fiction, it underscores the very real threat that comets represent and the importance of early detection and prevention efforts. To keep track of potential threats from space, scientists have developed what's known as the risk list, a catalog of near-Earth objects that pose a significant risk of collision with Earth. This list is constantly updated as new data becomes available, and it ranks asteroids based on their size, potential impact dates, and collision probabilities. Among the top 3 objects currently on this list are asteroids 2023 VD3, 1979 XB, and 2008 JL3. 2023 VD3 is a recently discovered asteroid with a diameter of about 650 feet. While relatively small compared to some other asteroids, its potential impact date in 2032 and its close approach to Earth have made it a significant concern. The probability of collision is low, but the potential devastation it could cause if it were to strike makes it a priority for monitoring. 1979 XB is a much larger asteroid with an estimated diameter of over 1,500 feet. Discovered decades ago, it has been closely monitored due to its size and potential impact date in the late 21st century. While the chance of collision is small, its massive size means it could cause catastrophic damage if it were to hit Earth. 2008 JL3 is another large asteroid on the risk list, measuring around 1,200 feet in diameter. It has a potential impact date in the 2080s, and while the likelihood of a collision is still being refined, Its inclusion on the list highlights the ongoing need for vigilance. These asteroids represent just a few of the many objects that are constantly being tracked and analyzed to assess the threat they pose to Earth. As our understanding of these celestial bodies grows, so too does our ability to predict and potentially prevent future impacts. At the heart of this tracking and prediction process is data science, an essential tool in the fight to protect Earth from dangerous asteroids. By analyzing vast amounts of data from telescopes, satellites, and other observational tools, data scientists can accurately predict the trajectories of NEOs, assess the risk of impact, and help develop strategies for deflection or mitigation. Data science isn't just crucial for tracking asteroids. It plays a vital role in many other fields as well. In healthcare, for example, data science is used to predict disease outbreaks and develop personalized treatment plans. In finance, it helps to identify market trends and prevent fraud. And in climate science, data analysis is key to understanding and mitigating the effects of global warming. The ability to process and interpret large data sets is becoming increasingly important across all areas of science and industry, making data science one of the most valuable skills of the 21st century. Detecting potentially hazardous near-Earth objects is a critical component of planetary defense, and systems like Linear play a vital role in this effort. Linear, along with other observatories and space missions, uses powerful telescopes to scan the skies for new asteroids and comets. By capturing images and analyzing their orbits, these systems can identify objects that might pose a risk to Earth. Once detected, these NEOs are monitored for any potential collision paths. However, these detection systems have limitations, especially when it comes to comets. Comets, with their often unpredictable orbits and short observation windows, can be challenging to track accurately. Their sudden appearance and rapid movement can sometimes make it difficult for current technology to detect them in time. Additionally, the vastness of space means that we can only monitor a fraction of the sky at any given moment, leaving a small but real chance that a dangerous object might go unnoticed until it's too late. In addition to detection, preparedness is crucial for dealing with potential asteroid impacts. NASA conducts hypothetical planetary defense exercises to simulate how the world would respond to an impending asteroid threat. These exercises involve a range of scenarios, from potential deflection missions to international cooperation and evacuation plans. One notable example is the recent Planetary Defense Conference exercise, where experts simulated the response to a hypothetical asteroid on a collision course with Earth. The exercise highlighted the importance of early detection, global coordination, and the need for effective communication strategies. The outcomes of these exercises not only provide valuable insights into the challenges of asteroid defense, but also help to refine and improve response plans, ensuring that we are better prepared for any future threats. In summary, while the dangers posed by near-Earth objects are real, the risk of a catastrophic asteroid impact is relatively low, thanks to our ongoing scientific monitoring and planetary defense efforts. With systems like Linear in place and NASA's proactive exercises, we are constantly working to detect and mitigate potential threats from space. It is essential to rely on credible sources for information about space threats to avoid misinformation and panic. Current scientific understanding and preparedness measures provide a reassuring perspective on this issue. To stay informed and help spread awareness about the facts behind asteroid threats, follow reputable news sources and share this video with others. By staying informed, we can all contribute to a more knowledgeable and prepared world.